Okay, hi guys. I'm going to try to take you through this rates and proportional relationships. This is the first link that you're going to have to work on. Make sure you sign in to Khan Academy. You can sign in using your Google account, okay? And then hit the link that will be in the notes and on the board. I have asked our substitute to please put that link on the board. And for you guys, just so you know, it's going to be bit.ly CHS math 8a. So bit.ly slash CHS capital, then capital M math 8 lowercase a. So this is the first exercise right here. So we're going to take a look at this. I'm going to try to work through this a little bit. So let me just grab a quick image here, and we're going to, let's see, copy that. I'm going to put it into my screen recorder. What happened to my screen recorder? Let's see if I can get this up there. Sorry about that. Had it up and running, must have somehow got closed. Pause this, all right. So we're going to paste this here, and we'll zoom in on it, okay? So basically here it says, Raquel takes her pulse in order to determine her resting heart rate, measured in beats per minute. So what we're learning about is this idea of rates, how fast things are moving. And rates are related, you have ratios. Okay, in this case here we have beats and minutes put together in a ratio. And the per part, so BPM, the per part is a fraction. So we're going to put the beats on top, and we're going to put the minutes on the bottom, okay, and make a fraction out of it. And that's all it really means, right? So it says, the graph below shows an ideal resting heart rate for someone, Raquel's height, weight, age, and general level of fitness. The x-coordinate represents minutes. So down here we're going to see on the x-axis, we're going to see how many minutes have gone by. And it says, and the y-coordinate, so that's up, tells me how many beats they've had, okay? And that's the y-axis. And it says, is Raquel's heart rate faster or slower than the ideal heart rate shown on the graph? All right, let's go back over here, see if we can grab this real quick from our problem. Sorry about that. Here we go. So we have a table and a graph. Okay, let's see. Hopefully I can get all of this here. So we're going to grab the table. Okay, copy that. Ooh boy, it's going to be ugly. Let's not do that. Let's try that again. Here we go. We got this right there. So my table. And paste that in here somewhere. Let's put it right over here. And then let me go ahead and get the graph. Okay, I'll get that graph over here. And grab that real quick. Copy that image and put that in here. We're going to analyze these two things together. Okay, so what we see is this is the ideal, this is the blue line is the ideal heart rate. So they said, if you look at the problem, it said the x-axis, remember we said the x-axis was minutes. So this is how many minutes have gone by. And the y-axis, it said, was the beats, heartbeats, right? So we're just curious if we're going to do a beats per minute. We're going to put the number of beats, and minute we're going to do for 1 minute. How many beats in 1 minute? So ideally this would be from 1 minute, I would just go up, that's 20, 40, 60, that's about 70. So about 70 beats per 1 minute is the target. Okay, is the target. So when we look at this question, starts to ask question. It says, Raquel takes her pulse in order to determine her resting heart rate. So her rate is 62 over 1 minute. 62 over 1 minute. Or 124 over 2 minutes. or 186 over 3 minutes. Well, that is, each of these they're all equal to each other. Okay. If I take 124 and divide it by 2, I get 62. If I take 186 divided by 3, I get 62. So it's 62 beats per 1 minute. And I can see that. Here's my beats, and there's 1 minute. So the question was, the ideal, the graph was ideal, the table was her, and they're asking, what's the question here? Is she slower or faster? So if she's at 62, she is slower than ideal. She is slower than ideal. So let's go in here and say if she's at 62, then her heart rate is slow at 62 is slower than this ideal, which is at 70. Okay, see how that works? All right, let's do a couple more of these problems real quick. Here is, all right, this is giving me also amount paid, a number of hours worked. Well, this would be asking about the hourly rate. The hourly rate is how much you get paid per hour. You guys understand that idea, right? So the idea is, you know, how much money, how many dollars per, right? I mean, we talk about getting a job. Oops. Yikes. That's why I write on my whiteboard instead of this. Let me grab that. Sorry about that. Let's just take that guy off there, and we will grab this thing and make it into a problem to work, okay? So the idea is that, let me get away from all that problem. Let's start a new problem here. So the idea is when you go get a job and they say, oh, we're paying you $5 or 10, let's say $10 an hour, right? So that's a rate, right? You put your dollars earned over your hours worked, right? And your base rate, if you get paid $10 per hour, it's $10, right? Per 1 hour. That's the base rate, right? Well, we want to, obviously what we're going to do is we're going to compare that here, see how much this person is getting paid. It says, Roberto is having his house painted. The job takes 3 days and pays the painter the same hourly rate every day. The cost of the job is in the chart below. Which of the following equations where H represents hours, so notice I'm marking that H, and P, capital P, represents the amount paid in dollars, represent an hourly pay rate that is greater than the painter's hourly pay rate. Well, we can figure out what the painter's pay rate, right? Well, how much did the painter get? Well, the painter got $300 over 5 hours. That's pretty good money, man. That is $60 per 1 hour. So you can put that in a calculator to figure that out. 300 divided by 5. This day they got 240 divided by 4. That's still 60. 360 divided by 6. So this is still a rate. The painter is getting paid $60 per hour. It's pretty good, right? All right. Now it says, which represents a pay rate higher? So this would be $6.5 for each hour. So that would be less, right? $6.50 for each hour. This is $50 for each hour. So that is still less than the 60. This one says 65 per hour, so that one is more, right? And it says choose all answers. I'm going to go back to the Khan Academy screen here. And let's see if we can see 65 would be more and 70 would be more, right? More than the 60. See how that works? So we've got to figure out what is the words per minute, right? Charlie is a very fast typer. You can type 700 words in 5 minutes. So essentially we're looking at a rate which is words per minute, right? As soon as we see a problem like that, bam, right? We know this is a ratio problem. This is a rate problem. And we don't freak out. Those are no big deal. We just got to know what the rate is that they're looking for. And in this case, it's really simple. They've got a table here, but it's interesting. They keep putting the table sideways, and they want words per minute, right? So I like writing it, the words per minute that they're saying. I like put the words first, the per is the divide, and the minutes on the bottom. Right? So that's all we're really going to do here. So how many words? 216 words in 1 minute. So that's Charlie's rate. That's an incredible rate, by the way. I've worked on my typing skills. I can't get over 100, and I'm probably more like 60 or 70 at this point. Okay, but, this is Charlie's speed, 216 words per minute. Oh, no, wait, I better read this again. It says, Charlie typed faster than any of his classmates. Took a test, showed he could type 700 words in 5 minutes. So, Charlie's 700 in 5 minutes. How does that, this is Charlie right here, right? How does Charlie's compare to the record, right? The record, yes, the record is really high, no wonder. Okay, so what we do is we take 700 divided by 5, right? You can do that on your calculator. You can ask Google for some help like this. Let's see, let me get Google to help me out. Okay, let's see. Maybe this is a dumb idea, but I'm going to give it a try. Okay. What is 700 divided by 5?
The answer is 140.
So this would be 140 words per 1 minute, right? So 140 words per minute is less than the 216 words in 1 minute. So Charlie is not faster. No, that's not correct. Charlie types slower. Yes, that is correct. And so I'm going to go back here and select B. Charlie types slower. Oops, close that out. Go over here and say he types slower and check it out. Okay, so that's the idea. This rates and proportional relationships, practice problems, okay? I want you to go through these until you feel really, really comfortable. I'm going to do one more, I guess, here. This is a speed problem. Speed is usually, we think about miles per hour, but it's some distance. So, oops, see what I do? I forget that I need to take a screenshot first, right? All right, and then that way I can write on it in my whiteboard. It's much better than trying to write on it in Khan Academy. So let me go over here. Got to do this really fast because I don't want to take too much of your time. I want to get you guys practicing this. All right, so the maximum recorded speed is usually some distance over some time. That's your speed, right? So normally we go miles per hour. That's like, oh, you're going so many miles per hour. In this case, they're using a different unit to measure the distance. They're going kilometers per hour, okay? So the antelope is 88.5. It can keep that up for 1 kilometer, okay? The distance D in kilometer the wildebeest can run in T hours is, okay, so this tells me they can go 80.5. The distance is equal to, so I got to read this here. The distance is equal to 80.5 kilometers for each hour, per hour. So if I read that, the wildebeest is going 80.5 and the antelope is 88.5. I think the antelope can run faster. Right? The antelope can run faster. So they're just asking you, can you recognize the rate here? Right? 80.5 for each hour. This is the distance in kilometers per hour. It's one way to write it, just like this. This is another way to write it, like a fraction. 88.5 kilometers per hour, written like a fraction. Right? They did a little fraction bar here. And that's really all they're asking you to be able to do. So I want you guys to work on that problem, okay? Oops, close that out and make sure you can see that we say the American antelope is the fastest. So there you have it, okay? Go ahead and get some practice done, and then you can do the second set.